Hello! Welcome to Out of Order, ArcGIS Arcade to play when you otherwise couldn't. I'm Jordan Carmona, and this presentation is Outrun themed. Arcade is named for the covered passageway. Apparently, that's what an arcade looks like. It follows in the Esri tradition of naming languages after streets and roads. Some people in the audience may remember another Arc language, Avenue. Well, that doesn't really flow with the Outrun vibe that we're looking for, so we're going to engage in some revisionist history and say that arcade was named for the 1980s phenomenon. So, without further ado, arcade. Now, I would have loved to see something like this 2 years ago. I started really using arcade this year, and it has absolutely changed the way that I work. My goal today is to introduce how it can be used for some basic web mapping, and I'm really just scratching the surface here. I hope that this piques your curiosity enough to start using it in your own workflows. So what's an expression language? An expression language is one where nearly every expression returns a result. So what's arcade? If you wanted to put it in a little box with a definition, it excels at creating custom visualizations, calculations. It's usable in ArcGIS Online, ArcPro, ArcGIS API for JavaScript, and the runtime SDKs. It is less like Python or R and more like a fancy Excel. But the real benefit is that everything happens on the fly. It is a great way to make a nicer web map, do some interesting calculations, all without the overhead of a full-blown script. While arcade is a great tool for a variety of uses, my introduction to this language came from a very specific lens. I didn't own the data, but I wanted to do stuff with it. What this had meant previously was that I'd copy data from a source, either external or from within my own organization, make the changes that I wanted, then host up a copy on ArcGIS Online, which is fine enough for one-offs. But when it needs to exist for a bit longer, or when people ask you to start maintaining it, then you run into the issue, should I automate this? And surprisingly, the answer was no. But before anyone gets up in arms, we still get to write code. This part is a live demo. I fly drones. We are going to consume some data from the FAA Open Data Portal and make it a bit more user-friendly. We're going to see how to create fields for derivative data, how to make more visually attractive fields, and symbolizing things based off of arcade. So, here's the demo. Don't mind me, I'm just demoing. Let's start with the FAA Open Data Portal. So you may not know this, but drones have to follow a lot of rules. One of those rules is that when they are in controlled airspace, they have to follow a flight ceiling restriction. The FAA publishes this. This is an Esri Open Data Portal, and we're going to go to the facility map. What I like about these open data sites are that you can grab a REST endpoint from this APIs tab. Can click on it, Control C, do what you gotta do. Now let's open up a map. So here's our map. It's Outrun. it already looks great, but let's go ahead and add in the data from the FAA just because we can. As you can tell, my mouse is super sensitive. Moving on, we paste it here. You'll want to get rid of the bit at the end to where it ends in probably 0, but any other integer number would work as well, but probably 0 is what you're looking for here. So let's add that layer. We'll turn off our super awesome layer. And just to show what the data looks like, let's go ahead and symbolize it based off of the ceiling, which is appropriately named ceiling. And we'll go by types. So as you can see here, there's a lot going on. I count 9 different types. Looks like the numbers go from 0 to 400 in increments of 50. Okay, click done. Now let's click on one of these tiles to take a look at what the data looks like. We have ceiling 400. We have another column beneath that saying feet. That's kind of silly. Yep, anytime you click on something, you're going to know it's in feet, and that doesn't change throughout the data set. A little quibble, we'll get to that later. Then we have some effective dates, when it was last edited, latitude, longitude, the call sign of the airport, a bunch of empty fields, the airspace letter, then what region it's in. So if you were going to consume this data, normally what you would do, you would have control over, which we can take a look at right now, is to configure the pop-up. Let's say we're interested in the ceiling, the unit, the airport's name, and what class the airspace is. We could do some things to clean up the name. But we're really limited in actually editing the underlying data. So if you were not using Arcade, this is about the best that you could clean something up, which is not super, well, almost. Let's do one more thing. There. So that's about the best that you could hope for with that. Okay, so let's look at some of the things that we can do with Arcade. Oh, look at that, so much nicer. We've got zeros, we've got no fly zones, we've got things in feet, things in meters. Airspace is now NATO phonetic. Ooh, now let's take a look at, wow, that is a great symbolization. Look at that, down to 5 classes, really makes use of our Outrun color palette. Let's take a look at that, and then we can browse some of the rest of the code in a nicer environment. So we can go to Edit Expression here, and this is where you will be writing Arcade. There's no dark mode yet. It's okay. It's okay. This is pretty simple stuff. What we're doing is we're creating a variable, calling it divide by 100. We are making it equal to the feature that we're, typing this in, which would be the facility map. We're calling it on the column ceiling. And then we're saying modulus 100. Modulus is a special type of division that just returns the remainder. So what happens here is that if the attribute is not divisible by 100, right? If it returns anything other than 0, then we are going to enter in an IIF statement, which is if it's true, return this. If it's false, return something else. So if after we subtract 50 from the number and it's equal to 0, then we'll call it a no-fly zone. Otherwise, we will grab the attribute number, subtract 50, and then using the text function, we will add the letters FT to the end to concatenate those two fields, right? We don't need a field that says feet all the time. We can just say FT at the end of the number. Otherwise, if it passes this test, right? If it is in fact divisible by 100 and it's equal to 0, we'll call it a no-fly zone, right? Because if you can't fly above 0 feet, obviously you can't fly. And if it is not equal to 0, we will return the number 100, 200, 300, 400 and add an FT. So that is what we're doing. You can test your functions right here and it'll give you an output as to what it looks like, right? It's going to say 300 feet and the value is a string. So that's pretty neat. This is how you would go, and you could click on these or you can type them out. You have some functions that you can use. The arcade page on the developers section of Esri.com is super awesome, and should be the first resource you go to. It's really great. The write-ups are really great. It's super. Anyway, and then we have some constants we'll talk about. The other cool thing is that you can look at all of the other expressions that you've written for this layer. So we can take a look. So if you have done something recently, you wanted to copy paste, or if you wanted to reference what you were doing somewhere else, you can check it out there. Anyway, so that's that. That's how you write Arcade inside of ArcGIS Online. Let's go back to looking at some of the other functions and how we created them. Okay. So this is the thing we just looked at, how to symbolize the flight ceiling. We don't really need to go over this again, but we will be looking at it later when we talk about what we did with some of the pop-ups. So this is how to change the airspace to NATO phonetic. We're using a simple when statement. When the airspace 1 column is equal to A, which is the double equality sign. Return alpha when it's B, return bravo, all the way down the end. You'll notice at the very end it says unknown. The when function requires you to provide a default value if none of the other values hit, right? So I know that there's not any other values, but still we add in something. So if there was some unknown airspace to anyone, it would be called unknown. So that's that. Here we are streamlining our ceiling value. You'll notice it looks super similar to the symbolization arcade function that we wrote. Again, we're dividing by 100. If it's not equal to 0, if it has anything, then it's going to be one of those 50 increments. Otherwise, return the number because it's, 100, 200, 300, whatever. Part of this is just breaking down your data and knowing what's there. Obviously, this neat of a script wouldn't work if you had additional increments, right? 25, 50, 75, then you'd have to write longer logic to make it all make sense. So one of the things about writing arcade is that a lot of what you're going to do is iterative, meaning you start small and then you go over it and add little bits and pieces. So this is that same function, but we're just adding a few things right now it's the IIF statement. So if it's equal to 0, it's a no-fly zone. Otherwise, return the letters FT to the end. But you can also do calculations. So for some reason, if you wanted to do meters, you would simply add that in as a multiplication, right? So the feet to meters conversion is multiplied 0.3048, and then you add an M to the end of that instead of an FT. Boom, you've got meters. Super great. And then I just wanted to show this as you can also add in mathematical functions. This rounds the meters, you know, up or down depending on 0.5. However, there's also a floor and a ceil function. So if you needed to, you could force your numbers to round up or force them to round down. Now you can set the rounding inside of your configure pop-ups window, but what you can't do is force it to round up or round down, right? So Arcade can save you some time by not having to go inside the configure pop-ups and click on some stuff, or it can do things that you otherwise couldn't, like forcing something to round up or round down. Okay, so we've got another live demo to do. This one is garage sales here in the city of McKinney. We'll look at how to link to external sites, condensing data, and making it more readable, and also referencing features in other layers. So let's take a look at that. Okay, sweet. Another super Outrun inspired web map. We can take a look at what we have going on with the pop-ups. Pretty simple. Sale soon, what type of sale it is. Then this big sale information column field that gives you a lot of great information all in a row. And then before we click on this, we also have our grid telling us how many garage sales are within that grid, which is super. That's probably one of my favorite things right now to do. Anyway, so if you clicked on more info, you would immediately be taken over to Google Maps. This is actually kind of impressive on a mobile device because it'll open up your Google Maps app, which is neat. But that's that. All right, so back to this presentation. Yeah, okay, great. Right, so we're going to review some of this code. We'll take a look at it. This is how we link to an external URL. Probably could have written it a little bit prettier, but this is what we've got. We create 3 variables. We keep our address within 2 columns inside of our schema. So that's why there are 2 address replace spaces variables. So we are using the replace function to grab the data out of our main address column 1. And anytime we see a blank space, we are replacing it with a plus sign. Because that's how the URL works for Google. URLs don't like spaces, so it'll break them. And then we do the same thing with the second main address column. Then we are just grabbing the first part of the Google Maps URL. And finally, in our address URL variable, we are using the concatenate function, which you feed it an array and it will smush them all together. So we've got the Google URL, our main address 1, a plus sign to bridge the gap between the 2 main addresses, and then we return that address URL. So on the back end, this is what it looks like there at the bottom. But for the user, you get just sent down to Google land. If If anyone wants to tell me how to make it say anything other than more info, that would be wicked sweet. But by default, it says more info. So the sale information column, what we're doing here is condensing fields, right? So all of those items exist as single attributes in our database, but that's not what we want to feed to our web map users. We want them to have something that ultimately is human readable and is not a struggle to understand. So the first thing we're doing is we have an actual date field, so 10/25/2019. However, if you ask me what day is 10/25/2019, I would tell you 25. But it's a Friday, right? One of the cool things that Arcade will do is actually parse your date fields for you. So by feeding it the keyword lowercase d 4 times, it will return the day of the week. By feeding it 4 capital M's, it returns you the fully written out month of the year, and 2 capital D's, the Arabic numeral for the day, right? So what that variable text date does is spits out Friday, comma, October 25th. Which is nice. It's a more human readable, easier to understand. Our variable sale times takes our sale type feature, which is in this example single family sale. We use the constant new line to again make our pop-up more readable, to break it onto another line. Then we say starts, then we insert the text date variable from above, we make another new line, then we have the string phrase scheduled for, and then we insert the length of sale attribute from our data set, and we return that variable. So altogether, just in 10 lines of code, we have condensed 3 fields and expanded out our date field to be more understandable to our users. Finally, cross-referencing geometry is super easy. This is 4 lines of code, really just 2 lines, but I did my best to make it formatted well. We have our variable search geometry, and we're calling the feature set by name function. We use $map when we're inside ArcGIS Online. If you were inside ArcPro, you would use $data store, and then we call our layer by name, which was permitted garage sales. Then we are returning a count of the number of intersects between our feature, which we're writing this arcade script for, against the search geometry variable, which is referencing permitted garage sales. So when you put all of that together, every time you click on a function, it runs this on the end user side and returns the number of intersections for a layer, which is super cool. I would like to see this kind of functionality to be used in symbolization, but we're just not there yet, right? The larger your data set is, the longer this function would take to run, and if you had this for an entire huge data set, it just wouldn't run at the moment. So that was a whirlwind tour of Arcade and a gentle introduction to Outrun. If you want to chat about anything, feel free to email or LinkedIn me. Also, I just really like Outrun. So who's gonna go home and use Arcade? What kind of stuff blew your mind? I would love to hear from you, and I don't think I'm gonna bother doing any post-production editing. So hope you liked it. Bye.